I'm Guo Cheng Guang, 12 years old, studying at one for NS High School, right now here. We're starting this course, and this is organic chemistry. So for this term, we already have one lesson. So in that first lesson, we had about organic compound and homologous series. So in this first part that we have is about the classification of organic compounds. Well, let me just briefly say again about these organic compounds here. So in an organic compound, there must be carbon, yes, but generally we must have a carbon chain. But there are some cases where we don't have a carbon chain, for example, methane. Then this is methane here, CH4. So this is one of those that do not have a carbon chain. And a carbon chain is just that bond between two carbons. Well, this type of bond, here, this is a bond. Well, we can call this, since it's between two carbons, we can call it the carbon chain. Well, but here there are also different other bonds. So let's just say, for example, this carbon and hydrogen. This type of bond, we can call it covalent bond. Well, this is actually also a covalent bond. So right now here, all these parts are covalent bonds. Well, how do these bonds form here? Well, let me just tell you, this bond here, well, we can call it the shared electron pair, since at the end of these two, there are actually electrons. So let's just say here, this carbon. So let's just take this as an example. We have two carbon. Then carbon. Let's think about the valence electron of carbon. So if we go horizontally, hydrogen and helium, well, that is the top. So it's 1 and 2. The other is lithium, beryllium, boron, carbon. So you have 4 of them. There are these 4. Well, there are also other elements with 4 valence electrons. So if you want to find some of them, you go vertically down. Carbon, silicon, germanium, tin, lead, fluorodium. All these, they also have 4 valence electrons there. Well, from this part, carbon, well, these bondless, wait, let me just draw these closer. Okay, at this part, we get hydrogens. Well, hydrogen, they only have 1, but from this part, from these, when they are linked together, every single atom, they must obtain the octet state. So octet for this carbon here, it will be 8 in the outmost layer. So it needs 8, but it only has 4. So then its proton inside, it will want to attract others, like it attract other electrons from these elements here. So then it will attract 1 already, 1, 2, 3, and 4 here. So it gets extra 4. It gets an extra 4. So 4 and 4 is just 8. So that means this carbon here already has obtained the octet state. So hydrogens, they also need to obtain that kind of state. So here, originally they have 1. After this bonding, they get 1 extra. So then they get 2. So that means these hydrogen, they're also octet. So that means from here, all of these atoms here, they have the octet state. So that means this is alright. But this bond, we also cannot confuse them, like, is it actually the electrons attracting each other? But electrons, they are both negative charges. How do they attract each other? Well, let me tell you, it's actually not these 2 electrons attracting each other. In reality, these 2 electrons, they are repelling each other. They're both negative, they are repelling each other. So how do they come together, and why would they actually be together? So carbon, although we say these 4 electrons on the outmost part, they have a shielding effect. But the shielding effect is not like a solid sphere here. If it is a solid sphere, then it's possible that it blocks out all. but it's only 4 electrons trying to go around. So then the proton inside might still be able to attract electrons from other atoms, for example, hydrogen here. So there's still a chance that it can attract the other electrons. So that is a possible way of how they are getting linked together. Another way is like if you force them together to become very close, then the electrons from hydrogen, they get into the shell of this electron from carbon. Then the proton, since it's already on its shell, so that means they cannot repel it away again. So that means this carbon here, then the protons will also attract that electron. So let's just say this carbon here. So what's actually happening? Let's just say we have these 4 electrons over here. Then after that, let's say you have this hydrogen. So then you have that 1 electron from hydrogen there. So then here from this hydrogen, you have 2 electrons. Then from carbon, although here only have 5, but beware, there are also other hydrogens. Wait. Then after that, there's also 1 more carbon over here. So from this part, that would be something like what you have from here. So hydrogen here, each of them have 2 of these electrons. Then from carbon, you have 4 groups of 2. That means you get 8 from here. So that's how they actually look like. It is. So beware, it's not actually the electrons attracting each other. The electrons in reality are repelling each other. So from here, we're already clear of how these bonds, they actually can be made here. Okay, so here is what they look like. Then we can start on our classification, our actual classification. So first of all, that we are going to have, wait, let me just erase all these. So first of all, from this part, what we're going to have will be our alkane. So alkane in this part, it is going for C. Well, there's N of C, then with hydrogen, 2N plus 2. So this is the general formula for alkane. So N from this part, it can be 1, 2, and so on, all those. So for alkane here, let's say for example, we have 1 carbon. So if you put it in, you have 4 hydrogen. So for this, what we call it methane. Then after that, 2. We have here ethane. Then 3 propane, then butane. Wait, here it just goes on. Propane, butane, pentane, hexane, heptane, octane, nonane, all those a lot. Nonane, then decane. Okay, so for these alkanes, you actually find them really often from here. Okay, and in the last lesson, what we had is if you put oxygen inside. If you add oxygen inside, like what we have those, like water, H2O, we have carbon dioxide, CO2, or carbon monoxide, CO, and there's others, or even carbon. So from this part, also we're saying about organic chemistry. We're mainly focusing on these organic compounds. Like just now, what I said, there can be water, H2O, which is inorganic compounds. In organic chemistry, we also need inorganic compounds, but we're mainly focusing on organic compounds here, okay? So from this part, that's the first that we have, alkane. Then the second part that we can have is what we call alkene. So you have to be careful. These two words, they only differ by one letter here. Alkane and alkene. So alkene here, it is C and H to N. That's what we have. But wait, N now it starts. Now they have different values here. N can only start from 2. So you go 2, 3, 4, and so on. Plus, you also have to be aware that we use N here like for natural numbers, since they cannot be decimals. You don't break up the atom, they add it inside. So that's what we have. So this is for our alkene now. Alkene, we start from 2. So then we have 4 hydrogen. How are we supposed to link them together? If we link them in the same way like this, let's see what will happen. If we link them in the same way, this carbon only has 6. It cannot obtain the octet state. This carbon also, but the hydrogens are already in this octet state. So how can we have 2 more for these carbons? Well, you cannot add more hydrogen, you cannot add others. So these carbons, they'll form a double bond. So from this part, this compound here, we just call it ethene here. But with this double bond, so we actually need to make a big difference here. These two. Here you have double bond, here you only have single bond. We do have different names to call them. Well, we call this part a saturated. This is saturated. This part, we call it unsaturated. Well, how can we understand these two words? Like, okay, so one way that we can understand them is each carbon, they want to find 3 hydrogen. So if they could find 3 hydrogen, well, why not 4? 4 is only for methane. That means if you want 4, only methane is possible. So that's why they want 3. So they want 3, or even if it's the middle, then they want 2. So from this, they want 3. If they could find 3, well, we can call them saturated here. That's what we have in this case. Each carbon can find 3 hydrogen. They carbon between themselves, they have their carbon chain. But in this case, these carbons, they cannot find 3 hydrogen each. They only can find 2 hydrogen each. So then, since they cannot find them, well, we can just understand it like that and call it like unsaturated. But if you want to make it saturated, first of all, you have to break one of these bonds, then you add 2 hydrogens. So that's what you need to have. Well, at the same time from these parts, okay, I said about these electrons, each of them, electrons are repelling. So this, we have another adjective to describe it. We can describe it as stable, since there are only 2 electrons repelling each other. But right now here, it is different. From here, we have a double bond. And at each of these, at the end of each, we have electrons. So that means it becomes 4 electrons in here. So it becomes 4 electrons trying to repel each other. So 4 electrons trying to repel each other, we're starting to call this unstable. Well, you know, you'll say if like you have triple bond or those others, they're even more unstable. So we do have different names for each of them. Well, I'm just going to draw one more, like for example, this 3. So here, in this double bond that we have, so 4 electrons repelling each other, that means they can be separated easily. And when they can get separated easily, that means these bonds, they can break easily. So when the bonds break, the process when we break the bond, we can call it cracking. Well, over here, if we want to change this compound into this kind of stable compound, well, if you want to do that, you can give it energy or even just increasing the temperature. Yep, you can increase the temperature, then one of these bonds break. After you can give it hydrogen, or you can give fluorine or chlorine, those types. So then they can go in. But at the same time over here, you also have to be really careful. Like for example, if you go on, after you get 3 of these carbons, only at the 2 ends, you can get 3 hydrogen. For the one in the middle, you only need 2 hydrogen. So you have to be aware of that. So it's only the end parts, they get 3 hydrogen. The middle parts, they only need 2. Well, this is because there's no middle part, so each of them will get 3. So that's how you get these things. Well, what if we draw C3H6? So in this part, we have 3 carbons. So what if we try to give one of them a single bond and the other with a double bond? Let's try that over here. Let's see whether we can get 6 hydrogens. So with this carbon over here, it already have one of these bonds here. So that means we need 3 more. Then in the middle, they have 3, so it only needs 1 more. Then this one at the end, you already have 2. You have already made 2 of these bonds, so we need 2 more hydrogen. And let's check whether this have 6 hydrogen. So you have 1, 2, 3, 4, 5, 6. Yes, so this is right. But you can just be aware of whether you like to put this double bond here or there. They're actually both same. And if you want to put this hydrogen here or down. So those different type of arrangement, although that kind is the same. Okay. So for this part that we have, you have to be careful here. Double bonds, single bonds, or sometimes even until triple bonds. So to break them down, this double bond here is simple. Just give it a little energy. But this bond here, although we call it stable, it's not permanently stable. It can still be broken down. But you need a lot of energy. You'll give it inside. Only if you have a lot of them, it's way more harder to break them than this kind of double bond. But even double bond, after you break one of them, the other one left will also become very hard to break. So that will be what we have for these parts of alkane and alkene for this time. So I hope that you can understand so far. So if you like our videos, don't forget to subscribe to our channel. We will see you in the next lesson. Thank you for your watching.